Hello, my name is Michael. I'm a technical support engineer here at Artec. Today, we're going to make a 3D model out of this Buddha figurine with the camera on my phone. We'll also make another 3D model with the use of this digital camera to test out the different versatile approaches. Now, let's take a look at the object itself. It has really intricate geometry. It has all those small carvings and consists of multiple different geometrical shapes. It has quite a unique texture, which is going to be of great use when it would come down to registering all of the photos that we capture. A few words about the setup. You could take two different approaches. You could either use the turntable and place the object onto it, or you could go around the object yourself. Both ways would work. In case you're using a turntable, please make sure that the background does not have any distinctive texture features. This way, we would ensure that the frames do not get mismatched and misregistered. A quick pro tip: you could use those dies in order to elevate the object from the surface. This way, you're going to get a much better experience with the reconstruction of the surface and later on erasing the unnecessary parts. You could see right here that the object is elevated, and it would be easy for us to use the cutoff plane selection in order to erase all of the unnecessary data. You could see the technical specifications of the computer that I'm using for this video appearing on the screen. You could find an extensive list of the system requirements for Artec Studio 19 photogrammetry on our support page in the respective article. I have placed the object onto an additional texture background. This would help out the algorithm in order to register all of the photos between each other. This way, we're going to get much better geometry and better registration of the frames. But I'm going to use it only for the first orientation of the object. For the other ones, I'm going to remove it, since our different photosets can get misregistered because of this additional texture background. For the first project, I'm going to use my smartphone. I'm going to record a video, which will be a source for the following photoset that we're going to extract from it. We're going to take photos of the object in multiple different orientations in order to fully cover its geometry. First of all, we're going to scan it upright. Then, we're going to place it in a different orientation and register two different photosets between each other. Now, let's move on from theory to practice. I'm going to take my phone and start recording a video. Now, the object is positioned in the upright position. It is going to be the first orientation for our photoset. I'm simply pointing the camera at the object and start rotating the turntable. It's crucial to scan the object from multiple different positions. We need to ensure the full coverage of the object so that we would get a proper reconstruction of the geometry and, respectively, the texture. I'm also trying to make sure that my fingers do not get in the way of the camera. And I think we're done for the first orientation. I can stop for now. Now, I'm going to position the object into the second orientation. I'm adding up the dice, laying it flat right here, and now I can record the second video. So right now we have a huge overlap of the geometry between those two photosets. This would help to register all of the photos to each other. We're going to extract those photos from the video later on, and it's supported natively in Artec Studio 19. So I think we're done, and now it's time to import our dataset into Artec Studio.
Alright, so now it is time to import our photos and videos into Artec Studio in order to create the 3D model out of them. I'm going to go into File, Import, go to Photos and Videos, and let's start off from the videos. I'm going to select all supported video files, and here you can see our two videos that we have captured with the object positioned in different orientations. I'm going to select both of them, and here you see an option to select the amount of frames per second that we're going to extract from the video. So this value actually corresponds not to the frame rate that we have recorded video with, but rather the amount of frames that are going to be extracted from the video from each of the frames. Okay, so I'm going to set it to 1 because we have an abundant amount of frames in our video. We've got the objects scanned from multiple different positions. So 1 frame per second should be enough. All right, so the import is complete. Now you can see on the right that we have 2 photo sets. So now it is time for the actual processing. Make sure that both of the photo sets are selected in the workspace. Then navigate to Tools and Sparse Reconstruction. Please press the Sparse Reconstruction button itself. We do not want to run the algorithm right away. We want to adjust some of the settings. So here in Artec Studio, there are 2 types of scene type reconstruction. We can either reconstruct an object or a scene. In our case, it's an object. And the scene, on the other hand, might be some huge area scanned with a drone, or a castle, for example, or a production room, and so on, so on. But in our case, we're going to leave it to object. Object orientation, we're going to leave by default. And here I'm going to optimize the sparse reconstruction for quality because I have quite a powerful PC and I would like to get the best quality out of the reconstruction as possible with the photos that we have created. Okay, and here I'm going to adjust one more setting. Here it is located under the advanced settings and it's called the object position. So in our case, the object position changes between the photo sets. Here you can see that our first video was recorded with the object positioned in the upright orientation, and our second photo set with the object lying flat on the rotating table. So now, once all the settings are adjusted, I'm going to run the algorithm. So here you might switch between the photos, the masks, and masked photos view. You can see all of the photos that got registered here in the sparse reconstruction entity. And let's take a look at the masks that have been adjusted automatically during the sparse reconstruction step. You might see that all of the masks look correct, so we don't have to adjust anything. Basically, the thing that is highlighted in white is the object itself, and everything else is not going to be reconstructed. So it's not going to affect the dense reconstruction of the object. So we might look through them, and it looks quite good. We may also go back to the photos view and take a look at the sort by error high to low. And here, let's go to the top of the list, and we can see that the highest error is approximately 2. That's actually quite good. That means that we do not have any failed photos. And the highest error is not that bad. But still, if we would like to get like the best result out of it, we may exclude the photos with the highest error. And for example, leave all the photos below 1.4. We're going to use them for the reconstruction of our final 3D object. You may understand the severity of the error by the color of this circle. So green means good, red means bad, and yeah, anything in between is pretty self-explanatory. Okay. So now it is time to create our 3D model itself. We're going to go to Tools, to Dense Reconstruction, and here we're going to adjust some of the settings. Once again, we have 2 options, normal or high. So basically, that's the level of detail that we're going to get. And once again, with my PC, I'm going to select the high level of details. The scene type, we have discussed it previously. We're going to leave it to object once again. And there is one more cool setting that we've got. It's called Show Preview. So you'll see what it does in a few seconds. So here in the viewport, you might see our very rough approximation of the model appearing. And basically, up until to the end of the algorithm, we're going to see the level of detail getting better, and it's quite entertaining to watch. Here is our final model. Now, let's prepare it for texturing. So now, once the dense reconstruction is completed, we've got to review our model. Just rotate it in the viewport, take a look at the fine details that got reconstructed, and if you're satisfied with the results, let's move on to further processing. So if we zoom in, you could see all those fine carvings, all those shapes preserved really well, and all of that is just from a video from a phone. So now, if I click onto the dense reconstruction in the workspace, we might see the poly count of this model. We've got more than 3 million polygons, and actually this huge amount is not necessary in order to represent this type of 3D surface. We've got to simplify it. This will help us to speed up the texturing algorithm, and this will help with further manipulations with the object. For example, upon the export into third-party software, or upon export into some sort of cloud services for display, and so on and so on. We might also see some of the objects floating around, some of the meshes which are not connected to the main model, and we're going to fix it with just a click. All right, so let's select only the dense reconstruction in the workspace, go to Tools, Mesh Optimization, and here right away you can see the Remove Small Objects option ticked. That's what we're going to use. So here we're going to select All Except Largest method in order to get rid of all those floating meshes disconnected from the largest main mesh. So you may see that quite fast. We got rid of them, and now we have just the main model itself. We might also heal bad polygons if we have any. Let's run it just in case. This is necessary for the export once again, so that we won't have any issues upon the export. So I'm taking a look at the model, and I see right here that we've got quite a good result, and I don't think that we need any other manipulations with that. So now it's time to reduce the poly count. Now, in the same menu, select the mesh simplification, and here let's simplify the model by triangle quantity. Let's set it to 1 million. Okay, this should be good enough. And just click Run. Okay, so the mesh simplification is completed, and if we zoom in and take a look at the previous non-simplified model and the simplified model, you could barely notice any difference. So the level of details was preserved because the mesh simplification algorithm is a smart algorithm that preserves the fine shapes and simplifies the surfaces that do not have as much details. Okay, so now let's move on to texturing. All right, so now let's move on to our final step, the texturing of the model. Let's go to the Texture tab, and right here we're going to select the Sparse Reconstruction 1 as a texture source for this model. We're also going to leave the texture size at 4K because the raw images, the raw footage, the video was recorded at 4K, so there is no sense in going above that. And now all we've got to do is click Apply. Okay, so here is the result that we've got. And on the left, before applying the texture, you could see this basic color correction appearing. But actually, we do not need to adjust any of that because the basic lighting that we used in the scene was quite good. So I'm going to leave it all at the default. But in case you have some issues or if the texture does not reflect the real life texture that you would like to see, you may adjust some of those settings. I'm going to leave them at default. Alright, so now let's review the result that we have got and prepare it for the export. If we take a look at the texture, we might actually turn off the lighting in the scene by clicking the L button, and here you might see just the base color. So the base color is just the texture, the raw texture that we have received, without any additional lighting or shading. So this result turned out quite good, thanks to the light setup that we had during the photograph taking. And you might see that the model is evenly lit from all of the different sides. So that's why it would look great with mostly any shading that we turn on. So that's why it's really important to prepare the objects and prepare the scene before taking the photographs in order to achieve the best results possible. For the final step, let's export this model with the texture. So now I'm going to select our model in the workspace. I'm going to click F2. And here I'm going to rename this. Now, once I get the correct name, I can go to File, Exports, Export Meshes. And here I would like to select the OBJ formats with PNG texture. Now all I've got to do is specify the path. Here I'm going to create a separate folder. Let's call it model. Now I'm selecting it and I may leave the export name empty. It will be taken from the workspace. Now I click OK. So once the export is completed, we can navigate back to this folder, and here we will see three files: the MTL file, the OBJ file, and the PNG file. So now this model is usable in any other software. You could simply import it back again, for example, into Artec Studio, or any other software that supports OBJ files, and you may work on it further on.
Let's test out a different approach. I'm going to take the camera and take photos with my camera. So I'm going to turn it on, and I'm going to take photos in the vertical orientation. We do recommend to take the photos in the single orientation. So for example, if you started out in the vertical orientation, all of the photos should be like that. I'm scanning in a spiral-like trajectory in order to fully cover the surface of the object. As a result, we're going to get some sort of a dome in order to ensure the proper coverage. So later on, I'm going to rotate the object to the second orientation and take the photos as I did with the videos that I took with the phone.
Okay, so now for the second project, we're going to do basically the same thing, but for the photos. There is a special thing about photo editing workflow. So that concerns the import of this data. If we have multiple orientations, it's better to divide them by different folders. As you might see here, I've done it already. So basically, you create a folder per each orientation of the object. Here we have just two orientations, so I've created two folders. And upon import into Artec Studio, we are going to have two different photo sets. So we've got to select our two folders and drag and drop both sets of photos as well. As well, you could do that via file imports, as we've done earlier. From now on, the processing of the photosets that we have received is going to be similar to the processing workflow that we had previously with the videos. So we're going to speed up the footage up until the results and compare them.
Here is the resulting model. The carvings present on the real-life object are clearly visible, and small details are preserved in the 3D model. Actually, you could use photogrammetry on pretty much anything that comes to mind, from a small bug, using a macro lens, to full-sized buildings, using a drone. Photogrammetry can be used for scanning both hard surface objects, such as a screwdriver, ship propeller, and organic shapes, for example plants and different stuff.
Thank you for watching this video. Now, you know how to use Artec Studio 19 photogrammetry. Please, feel free to download Artec Studio 19 trial and test this new feature out yourself. This version is completely free of charge. All you need is a compatible computer, camera, and some cool objects to scan. Enjoy! See you next time!